Hey there, science fans, Bill Nye here, and boy, do I have a treat for you. We're diving headfirst into the amazing world of physics. Physics is like the instruction manual for the universe. It helps us understand how everything works, from the tiniest atom to the largest galaxy. Whether you're throwing a baseball, riding a bike, or just standing still, physics is in action. So buckle up, get ready to explore the fascinating world of motion, forces, energy, and waves. Let's get moving. In physics, motion is all about how objects change their position over time. Think about a car speeding down the highway or a ball flying through the air. That's motion in action. We can describe motion in terms of speed, which tells us how fast something is going, and direction, which tells us where it's headed. So next time you see something on the move, remember that's physics at play. Now let's talk about the mastermind behind our understanding of motion, Sir Isaac Newton. Newton's 3 laws of motion are like the traffic rules for the entire universe. His first law, the law of inertia, says that an object at rest stays at rest, and an object in motion stays in motion at the same speed and direction, unless acted upon by an unbalanced force. Basically, things like to keep doing what they're already doing. His second law tells us that force equals mass times acceleration, F = ma. This means that the heavier an object is, the more force it takes to get it moving or to change its motion. And finally, his third law states that for every action, there is an equal and opposite reaction. So, when you jump on a trampoline, you're pushing down on it and it's pushing right back up on you, sending you flying. Force is a big deal in physics. It's any interaction that, when unopposed, will change the motion of an object. Imagine pushing a shopping cart. You're applying force to get it moving. Forces can be pushes or pulls, and they come in many different forms like gravity, friction, and magnetism. They can make objects start moving, stop moving, or change direction. Think about playing tug of war. Both sides are applying force to the rope, and the winner is the one who can exert the greater force. Section 5. Work and energy. The dynamic duo. Work and energy go together like peanut butter and jelly. In physics, work is done when a force causes an object to move a certain distance. For example, when you lift a heavy box, you're doing work against gravity. Energy, on the other hand, is the ability to do work. It's like the fuel that powers everything around us. We need energy to run, to play, to think. Basically, to do anything at all. Section 6. Types of energy, from potential to kinetic and beyond. Energy comes in many different forms, but 2 of the most important are potential energy and kinetic energy. Potential energy is stored energy that an object has due to its position or state. Think about a roller coaster at the top of a hill. It has a lot of potential energy because of its height. Kinetic energy, on the other hand, is the energy of motion. As the roller coaster races down the hill, its potential energy is converted into kinetic energy. Other forms of energy include thermal energy, light energy, and sound energy. The law of conservation of energy tells us that energy cannot be created or destroyed, only transformed from one form to another. So the total amount of energy in the universe always stays the same, even though it might change forms along the way. Section 7. Waves, riding the crest. Now let's catch a wave. Waves are disturbances that travel through space and time, transferring energy without transferring matter. Think about dropping a pebble into a pond. The ripples that spread out from the point of impact are waves. Waves are everywhere. Light waves help us see, sound waves help us hear, and even earthquakes are caused by seismic waves traveling through the earth. Section 8. Types of waves, from sound to light. Waves come in different flavors too. We've got transverse waves, where the disturbance is perpendicular to the direction the wave travels, like the waves on a string. Then there are longitudinal waves, where the disturbance is parallel to the direction the wave travels, like sound waves. Light waves are a special type of transverse wave called electromagnetic waves, which can travel through the vacuum of space. From the radio waves that bring music to our ears to the X-rays that doctors use to see inside our bodies, electromagnetic waves play a vital role in our lives. Section 9. Conclusion. Physics rocks. So there you have it, folks. We've explored the fundamentals of physics, from motion and forces to energy and waves. Physics is more than just equations and formulas. It's the key to understanding the world around us and beyond. So keep asking questions, keep experimenting, and keep exploring the wonders of physics. Remember, science rules.